Here we are, Chapter 5, Unit 5, Mom Review. Probability, folks. All the P of A's, B's given A's, C's, A or B, A and B, independent, disjoint, mutually exclusive, all that jazz. Real quick, the only formulas you get in your packet are right here. Right there. So I will talk about these two throughout, but this is the A or B formula. And this one over here is the conditional formula. So they'll come up a lot. This is A given B is the way it's written, okay? So that's all you get for your formula sheet. Let's dive in. Number one, if you haven't yet, draw your Venn diagram. It's going to be very, very helpful. And then fill it in. The probability that A happens is 44. B is 52, A and B, and this is the middle, is 11%. Now, when I go to fill in this section here, a lot of kids just go, well, 44. Nope. It's got to be 44 minus 11, so it's got to be 33, right? Because this entire circle has to be 44% total. Likewise, the B circle has to be 52% total. So I'm going to do 52 minus 11. So we got 41. All right, now we can dive in. Here's A or B, and look, I just copied the formula straight off your packet, and they gave me everything I need right there. So you add them up and subtract the overlap. Pretty straightforward, all right? It'll be just 44 plus 52 minus the 11 overlap. Because if I add up 44 and then I add up 52, I have counted this 11 twice, so I subtract it, okay? And there you go, 85%. Part B, with the Venn diagram, it's not that bad. What this means is A happens, and what does this mean? B does not happen. So again, this is A and not B. So where does that happen in my picture? A happens, okay, that happens here, but B cannot happen, so it can't be those, leaving you just with 33%, that part of the circle, right? So again, B can't happen, so you can cross those off, and A has to happen. This is the flip-flop of that. It says A complement, meaning not A. Not A. A cannot happen, and B must happen. So that would be not these two, and B happens 41% of the time. Now we get conditional, okay? This one, the first one is B given A, and then A given B. I've written them both down here, both ways. This is B given A, this is A given B. And we can just do what the formula says. So for the first one, the numerator is the probability they both happen, okay? And if I can zoom out a little bit, that's 11%, all right? So 0.11 divided by the probability that A happens. The total probability that A happens, this one right here, not the 33%, the overall probability that A happens, 44%. My numbers work out nicely. That's 1/4, so I have just 25%. But you can divide that on your calculator. The next one is the reverse. A, given that B happened. So that's this one. I just reversed all the B's and A's in these formulas. So the numerator, again, is still the probability that they both happen, but the denominator is now the probability of B happening, which again is here, not the 41. It's the 52. So 11 divided by 52. You will need your calculator to get the decimal, and I don't know how to round it. Oh, it says round it to 2 decimals today. So I would round that to 21%. All right. Are they disjoint events? No, they can occur at the same time because that's the 11% in the middle. If these circles did not overlap, they would be disjoint, but they do overlap. Are they independent? Oh, okay. Now, there are two ways to check this right here. Unfortunately, both of these, neither one is on your formula packet. One is that the probability of A given B equals the probability of A. And the other one is to know that the probability that they both happen is the same as the probability of A happening followed by B happening. Let's do this one because we already have the information. We already have this right here. We did this right here. We got 21%, right? Does 21% is this. Is that the same as the probability of A? No, the probability of A is 44% up here. So I think all of you should be getting a no here, okay? All of you. If you did the other one, by the way, this doesn't check out because the probability of A given A and B happening at the same time is 11. The probability of A is 44 and the probability of B is 52. And when you multiply those, you don't get 11, right? 44 times 52 is 22. So this is not equal, so they are not independent. Okay, next one. Number 2. It tells me A is 25%, B is 53%, and it tells me they're independent. Okay, so what's the probability of A and B? So back down here to my independent stuff. If they're independent, let me get rid of this. The probability of A and B equals simply A times B. And they gave me A and B. So I simply need to multiply those two together because it told me they're independent. So I know these two are equal. That's it. 0.25, and that's it. So if you see, round it to 2 decimals, it says so 0.13. That's it for number 2. Number 3, it gives me the probability of A and B, and it gives me a conditional probability. It gives me this one right here. Find the following: probability of A and B and the probability of A or B. So I'm going to go in order here. I'm going to start with A and B because if I look at this, they gave me this, right? And then they also gave me this, the denominator right here. The only part I don't have in this setup, so it gave me this and it gave me this. The only thing I don't have is the numerator there. So let me set this up. The probability of A given B is 28. I know that equals what I'm looking for, the probability of A and B, over the probability of B, but they told me that is 59 right here. So to solve this, I simply need to, my Apple Pencil's acting up. Just trying to, there we go. Just need to multiply both sides by 59. And I'll have the answer. So it's just 28% times 59%. And I have 0.1652. Oh, round it to 2 decimals, it says 0.17. Now, moving on, probability of A or B. I'm going to go back right here. It's this formula, right? The A or B formula. What ingredients do I need? I need probability of A, which I have right here. I need the probability of B, which I have right here. And I need the probability of A and B, which I just found right here. So I have everything I need. So it would be 0.34 plus 0.59 minus the answer I just found. as I type this in, I'm wondering if it's going to be picky about how we round. Well, I guess you'll find out when you type it in, won't you? So I'm getting 76% for mine. I'm wondering if this number here, if it would let you round it or if that's going to be an issue. Meaning, I recall it was on the calculator, this was really 0.1652. You might want to put that down here and then only round your final answer. Number 4, it gives me A, it gives me B. It says they are disjoint. So what does that mean? That means they cannot happen at the same time. It means I've got circle A, and over here, it's completely separate, I've got circle B, and A is 22, B is 47. I'm going to go out of order here. So what's the probability that they happen at the same time? This is 0. They don't overlap. They are disjoint. They cannot happen at the same time. So now if I say, what's the probability that A or B happens? Back to this formula again, right? A or B happens. Probability of A is 22%. Probability of B is 47%. And the probability that they both happen is 0. So it's really simply 22 plus 47. So 69% of the time. Boom. Number 5. This one is about, I think there's various contexts. Mine is about kids that like stats and kids that like econ. 38% like stats, 37% like econ, and 14% like both. So in my diagram, for me, my 14% is the middle. Let's see, where can I make this a little bit larger? Let's go here. Sorry for I think that'll do. Oops. So 14% in the middle. Remember, then I'm going to do 38 minus 14 to get 24 for there. And I'm going to do 37 minus 14 as well to get 23 right there. I do think this question gets at kids that don't like either one. I think it does. So if I add up those 3 numbers, I get 61, and if I do 1 minus 61, that means there are 39% of kids on the outside of this tree diagram looking in. Let me get rid of this distracting work. So I'm going to use that for the whole thing. Part A. Probability somebody likes stats or econ. Well, again, where's my A or B formula? A or B is when you add A plus B and you subtract the overlap. So it's just going to be 38 plus 37 minus 14, which is 75 minus 14. So I think it's 61%. It's also, you could just say it's this plus this plus this. You're going to get 61%. Because or means where are the kids that like one of those things or they like both? So you would just add up all 3 of these if you want to go that route. Or you follow the formula. A plus B minus A and B. B, they don't like economics, but they did like stats. That would be these kids. They don't like econ, but they do like stats. 24%. The Venn diagram helps so much. They don't like econ, and they don't like stats. That would be that number. See, I thought we needed that. Those are the kids that don't like either class. D, they liked econ, okay, so they have to be in this circle, but they did not like stats. That would be this right here, right? They like econ, but they don't like stats. E, they don't like stats. Oh, given. Okay. Probability, no stats, given that they like econ. So you can use the conditional formula. The denominator is the probability of the given. The numerator is the probability of both. meaning no stats and econ. So what are these? So the numerator, where are the people that don't like stats and they like econ? That's right here. That's 23%. So that's my numerator. My denominator is the probability of just econ by itself, which is the whole econ circle, or it's also right here. It's 37%. And then you divide that and write your decimal accordingly. One other way to think about a condition, which is a more general way to go at it, the condition limits you to pick from that group. I must pick from here, from the econ circle, which is 37%. And then within that circle, how many people do not like stats? Well, that would be the 23%. That's who you are left to pick from. E, is liking stats and econ mutually exclusive? Well, can they happen at the same time? Yes, they can. So they are not exclusive because they do overlap. Is stats and econ, is liking them independent or dependent? So again, you can check either one of these. I'm gonna just use number 2. The probability of A and B is 14%. Does that equal, question mark, the probability of stats times the probability of econ? And those are 38 and 37. I don't think they are, but let's just make sure. And nope, that does not equal. Oh, it's really close. You might be thinking, I'll look the other way. It has to be, folks, it has to be exactly 14. It's really, really close, but it is not. So they are dependent. Meaning liking one of those classes has an impact on the probability of liking the other class. 6, I've helped lots of you on this one. This is a tree diagram. An incident rate means in the whole population, for me, 2% of the population have it. They have the disease. And then going the other way, the rest of the population doesn't have it. So they do not have it. Okay? Then each group can take a test to see if they have it. And you can get a positive test or a negative test for both groups. Right? So I'm just going to duplicate that and throw that down there. And it says more about that. It says when you have it, you get a positive 92% of the time. Let's color code this. So that's this one, 92% of the time, which means you get a negative the rest of the time. Okay. When you don't have it, you get a false positive 4% of the time. That's right here. And then 96% would be there. All right. The question, this is very clever. The probability that a person who tests positive actually has it. What is often overlooked is a person who tests positive is a condition. It is a given condition. So this is really the probability if somebody has the disease, they have it, given they had a positive test result. So I need to break this down using what I know about conditional probability, which again is right here, right? The probability of the condition goes on the bottom, and the numerator is the probability of both A and B. So the bottom, again, is the probability of the condition, probability of a positive test. The numerator is the probability of both things. You have it, and you had a positive test. Okay, have it and positive test. Okay, plus signs that mean positive. So what I need to do is focus in on the tree to get this probability and this probability. Because these are the two branches that had positive test results, which gives me this. So remember, if you want these two events to happen back to back in a row, you multiply them. So this top branch is 0.02 times 0.92, and this branch is 0.98 times 0.04. Let me take time here and write those down. So 0.0184 and okay. So I don't really need to look at the negative outcomes because that's not part of what I need. So my denominator is the probability of a positive test. That happened in both of these, so I need to add those up. Let me just do some copying. Run out of room. So when you run out of room, make more room. Okay, so the denominator is the two ways to get a positive test. Another way to think about this, here, let me get the number first, or to understand it, is that that's about 5.7%. So in other words, in this situation, 5.7% of people will get a positive test. Of the people with the positive test, how many of them actually had it? That's this group. So that is the people that have it and they got a positive test. So that is my numerator. And then I divide it to get my percentage. So long story short, my final answer is what's on my calculator right there. 0.32 rounded to 2 decimal places. Whew, number 7. 400 subjects were surveyed about their feelings about pizza. Everybody loves pizza. They should. These are nice raw counts or frequencies. They're not percentages. Mine has 400 people total. Okay. And then we have like 5 probability questions. What's the probability the subject is in this age group, given that they dislike pizza? The condition limits your choices. The condition limits your denominator. So it's limiting me to people that dislike pizza. So I'm going to be limited to this row. So my new denominator is 132. Of that row, I have to pick from that row. I'm limited to that row. I have to pick people that are 18 to 24 years old, which is 22. And then, of course, get your decimal. Okay, so 0.17. Okay, next, let me clear my table off. What's the probability that they dislike pizza? It's pretty straightforward. There's no condition. So disliking pizza, that's 132 people. There's no condition, so it's out of 140, or it's out of 400 people. And of course, get your decimal. That's 33%. Next, what's the probability they're in this age group or they like pizza? Okay. In that age group, 35 to 55, boom. Or they like pizza, boom. So you might be thinking, okay, 62 plus 74, you're on the right track. But then you have to minus the 11 because you have counted them twice. 62 plus 74 minus 11. So there are 125 people in the table that like pizza, or they're 35 to 55, or both. Now, you could treat this entire thing as a probability if you wanted. They're all technically out of 400. each one. But they have a common denominator the whole way through, so that's not going to change nothing. So I got 31 if you round it, 0.3125. Okay, put that up there. The fourth one, it has a condition. I put it at the beginning. So I'm going to highlight my condition because I'm limited to them. Given the subject is 70, 70-year-olds are in this category. So I'm limited to these 200 people. So my denominator is 200. In that column, how many of them like pizza? And that's 37. 37 out of 200. And then round it to 19. Last one, probability someone is 55 and older and they like pizza. So this is the both. Where are the people that like both? There is no condition here. It is simply this number here. They have both of those characteristics out of 400 to get it to be a probability. And we are done. We have 9%. See ya.